Download this code from codegive.com, link in the description below. Python timeit, a deep dive into timing code execution. The timeit module in Python is a powerful tool for accurately measuring the execution time of small code snippets. It's crucial for performance optimization, comparing algorithms, and understanding the efficiency of your code. This tutorial will cover timeit's functionality in detail, providing examples and explanations to help you master its usage. 1. Basic usage ***. The simplest way to use timeit is with its timeit function. It takes the code snippet as a string and optionally the number of repetitions, number, as arguments. It returns the total time taken to execute the code the specified number of times. This will run the code snippet 100,000 times and print the total execution time. The .6f in the f string formats the output to 6 decimal places for precision. Note that this includes the overhead of the loop itself, but for large numbers of iterations, this overhead becomes negligible compared to the code's execution time. 2. Using timer class ***. For more control and flexibility, use the timer class. It offers greater customization options. The timer object allows you to measure the time for a specific number of repetitions using timeit. We then calculate the average time per execution by dividing the total time by the number of repetitions. This provides a more meaningful measure of the code's performance. 3. Setup statements ***. Often, you need to initialize variables or import modules before running your code. The setup argument allows you to specify code that's executed only once before the timed code. Here, setup_code generates a list of 1000 random numbers. This list is created once before the timed code, which calculates the sum, runs repeatedly. This ensures that the timing is not affected by the time it takes to generate the data. 4. Using functions ***. You can time the execution of functions. Important here is the setup equals from __main___ import my_ function. This imports the function my_ function into the namespace where timeit will run the code. Without this, timeit wouldn't know what my_ function is. 5. Statement versus function timing ***. While you can time functions directly, there's a subtle difference between timing a function call versus a statement containing a function call. Let's illustrate. You'll likely observe a slight difference. Assigning the result to a variable, result equals my_func, introduces a small amount of additional overhead. For simple functions, this difference is often negligible, but for performance-critical sections, it's worth being aware of. 6. Repeats and best time ***. For even more robust measurements, timeit allows you to run the timing multiple times, repeat, and take the best, fastest, result. This helps to mitigate the impact of system noise and variations in execution time. This runs the code 3 times and reports the best, minimum, time. This reduces the impact of transient system load or other random fluctuations. 7. Global versus local variables ***. Be cautious about how you handle variables in your setup and code snippets. Variables defined in the setup are available globally within the timed code, whereas variables defined directly in the timed code are treated as local. Understanding this is crucial to avoid unintended consequences. Conclusion ***. Timeit is an invaluable tool for any Python programmer seeking to understand and improve the performance of their code. By mastering its features, including the use of the timer class, setup statements, functions, repeats, and understanding the subtle differences in timing approaches, you can accurately and efficiently profile your code and make informed decisions about optimization strategies. Remember to always use a sufficient number of repetitions to get statistically meaningful results and consider the impact of system overhead in your interpretations.